Hello everyone. This is the second video in a series of videos going over how to program using the Arduino. In this video, we are going to write code to control an LED light and make it blink at a certain rate. We will also be going over the difference between a digital and analog signal, the built-in functions pinMode, digitalWrite, and delay, and we will also talk a little bit about declaring variables. So let me first show you a picture of my setup here. I have an LED light connected in series with a 1000 ohm or 1 kilo ohm resistor. The positive side of the LED light, or the long leg side of the LED light, I've got connected to digital pin 9, and it can go in any digital pin that you'd like, but it has to be a digital pin. And then the other end of the circuit I have connected to ground. So if you need to, go ahead and pause the video so you can create this circuit with your Arduino and breadboard as I have it. Now before jumping into the code, I want to talk briefly about the difference between digital and analog signals. So for a digital signal, I want you to think about a light switch. A light switch only gives you two options. You can either turn the light on or off. And this is effectively what a digital signal is. A digital signal is a signal that can only take two values. This can be called on or off, but it will also be called high or low, or maybe even 1 and 0. This is in contrast to an analog signal. For an analog signal, I want you to think about controlling the volume, say on the radio. Yes, the volume can be on or off, or the sound can be on or off, but the volume level takes many different values. It's either off, or maybe it's quiet, or loud, or louder, or super loud. It can take lots of different values between just on or off. And this is effectively what an analog signal is. It's a signal that can take any one of a number of values between on and off. Okay, so now let's jump into our code. Go ahead and open up a new sketch. And what we'll do with the sketch is the first thing we're going to do is go ahead and save it. The reason we want to save it is because when we go ahead and upload it to our Arduino, it's going to ask us to save anyway, so let's go ahead and do it now. I'm going to call this Blink Demo. And again, as always, the first thing we're going to do is we're going to create a block comment at the top and create our documentation. So again, say who it's created by, give the date that it's created. Happy Valentine's Day, everyone. And then also a quick blurb about what the code is doing. So again, this code will make an LED light blink at a certain rate. Okay, so the first thing we're going to do here is we're going to declare a variable. And that's going to look something like this. So we're going to say LED pin is equal to 9. Now what we're going for here is that we're trying to say that whenever the Arduino sees from this point on the word LED pin, or the variable LED pin, it's going to see that and it's going to read it as the number 9. Now there's a couple more things we need here. First, we need to tell the Arduino what kind of variable this is. And in this video, and in most videos in this series, we're going to stick with the variable type integer, or int. And so basically what this means is that now the Arduino knows when it sees LED pin, it's going to get an integer value. And the integer value is, say, a negative number like -10 or -5, -1, but it could also be 0 or 1, 2, 3, whatever, any integer number. Another thing that we're going to need at the end of this line of code is a semicolon. Remember last time I said that the syntax of a programming language is very much like the grammar of a spoken language. In this analogy, you can think of the semicolon as like a period. This semicolon kind of ends the statement. And if we don't have this semicolon here, then we're going to get a syntax error when we try and compile the code, and the code won't run. And in most cases, every line of code that we write is going to need a semicolon. There's some exceptions, but for the most part, we're always going to need that semicolon. And then we really want to get into the habit of commenting every line of code that we write. So again, just a simple short comment saying what this line of code means or what it does. So what this line of code is saying is that our LED is connected to pin 9. Now in void setup, we're going to be telling the Arduino for any pins that we're using, what are we using that pin for? So we're going to use the built-in function pinMode, and this function is going to take two inputs, take two variables. So the first thing that we need to tell the Arduino is what pin are we talking about, and in this case we're talking about the LED pin, which again is pin 9 in my case. The second thing that we need to do is we need to tell the Arduino whether or not this pin is an input or an output. So when we say that a pin is an input, what we mean is that we're reading some information from the pin, or you can think of it as we're asking the pin, hey pin, what's going on there? What's going on in that pin? On the other side of that, we have an output, where an output is, you can think of us sending information to the pin, or we're telling the pin to do something. We're saying, hey pin, do this or do that. So in this case, we're going to be telling the pin to either turn on or turn off. So it's going to be an output. And then again, just like before, we need a semicolon to end this line of code and a comment saying what we're doing here. So the LED pin is an output. And then lastly, within this loop, we're going to tell the Arduino to turn the light on and then turn it off. So in order to turn it on, we're going to need to use the built-in function digitalWrite. And it's digitalWrite because we're using a digital pin. We're going to be sending a digital signal. So remember, a digital signal is either on or off, high or low, 1 or 0, something like that. It can only take two values. And just like pinMode, we first need to tell it what pin we're talking about. So we're going to be writing to LED pin. Or again, for me, that's pin 9. And now we need to tell it what value to take. And for the digitalWrite, it will accept values of high or low. So we're going to be sending it to high or on. Again, add the semicolon to make sure we're ending that statement, and a comment, turn the LED on. And then now we want to turn it off. So we can do something very similar. We can do a digitalWrite. Again, tell it we're writing to the LED pin. And now we're turning it off, so we're not setting it to high, but we're setting it to low. Again, end that statement with the semicolon, and now add the comment, we're turning the LED off. Now in a certain sense, this code will work exactly how we intend it to. It's going to get to the void loop, it's going to digitalWrite to the LED pin high, or it's going to turn it off, or turn it on, excuse me, and then it's going to turn it off. And then it will go back up here, turn it on, turn it off, turn it on, turn it off. The problem is that the Arduino software is going to run this code so quickly that we're not actually going to be able to perceive that it's turning on and off. It's just going to look like it's on all the time, somewhat dimly. So what we need to do is we need to add some delays. So we're going to use the built-in function called delay. And the delay function takes one integer value, and that integer value is going to tell you how many milliseconds to delay. So in this case, we're going to delay it for 1,000 milliseconds, or 1 second. Again, we have to have the semicolon here, and we're going to add the comment, delay the code for 1,000 milliseconds. And then so now we've got it's turning on, waiting 1,000 milliseconds, and then we're going to have it turn off, and we're going to do another delay. So delay 1,000, again the semicolon to end the statement, and again add a comment, again delay the code for 1,000 milliseconds. And then that's it, our code is done. We could go ahead and hit the check mark to verify that the code has no syntax errors. But if we hit upload, it's going to compile the sketch first, check for those syntax errors, and then upload it to the Arduino. So let's go ahead and just hit upload. And while that's uploading, I want to point out some common syntax errors that you might get at this point. So one, if you didn't declare the LED pin as a certain type of variable, for us it's an integer, you're going to get a syntax error. You also need to make sure that you have these semicolons at the end of each one of your statements, otherwise you're going to get syntax errors, and the code will not run. And then lastly, you'll notice that all these words that we use, the int, the pinMode, output, digitalWrite, high, delay, low, when we typed out these words, they changed color. So, some of them are orange, some of them are blue. These are recognized words by the Arduino software. And we have to make sure that we write them out exactly as they are. So hi, for instance, is in all capital letters. digitalWrite, the W is capital and everything else is lowercase. So double check and make sure that all of these are written out exactly as they are here. Otherwise, the code will not work. Okay, so the code is uploaded to the board. Let's go ahead and take a look at it. You see here that the light is turning on, and it's waiting 1 second, and then turning off, waiting 1 second, and then turning on, and waiting 1 second, and so on forever. It'll keep doing this until we unplug our Arduino. As a challenge for you, I'd like you to modify this code to make the LED light blink in the pattern of SOS, the International Sign of Distress. The SOS pattern is 3 short blinks, then 3 long blinks, and then 3 short blinks. And then this would repeat over and over again. And maybe we'll say that a short blink has a delay of maybe 250 milliseconds, and a long blink has a delay of 1 second. So go ahead and challenge yourself. Try and write this code to get your LED light to blink in the pattern of SOS. This was the second video going over how to program with the Arduino. I hope you found this video useful, and I look forward to seeing you in the next video.